Alright, so in this video I'm gonna be explaining another important paper with the title Estimation of Graph Features based on random walks using neighbors properties. This paper in 2024. Using random walks for sampling has proven advantages in assessing the characteristics of large and unknown social networks. Several algorithms based on random walks have been introduced in recent years. In the practical application of social network sampling, there is a recurrent reliance on an application programming interface for obtaining adjacent nodes. However, owing to constraints in set to query frequency and associated API expenses, it is preferable to minimize API calls during the feature estimation process. So in this study, considering the acquisition of neighboring nodes as a cost factor, we introduce a feature estimation algorithm that outperforms existing algorithms in terms of accuracy. Through experiments that simulate sampling on unknown graphs, we demonstrate the superior accuracy of our proposed algorithm when compared to existing alternatives. So we focus on the APIs which enable acquiring the degree information and properties to be estimated for each adjacent node when querying information about them. So when querying the list of adjacent nodes for node v sub I, we assume that the out degree and in degree and properties of any node within can be obtained simultaneously. And we treat the frequency of acquiring adjacent nodes as a cost. We assume that a single instant of adjacent node acquisition allows for simultaneous retrieval of n of sub vi and n of out of sub vi. And regardless of the number of adjacent nodes, we assume that all adjacent nodes can be obtained at a fixed cost of 1. In the context of distribution, if the condition is satisfied, it indicates that the distribution serves as a steady-state distribution for a Markov chain governed by the probability transition matrix P. In the case of an ergodic Markov chain determined by P, there is a singular and unique steady-state distribution pi. And for any function, the following holds when the following holds as t approaches infinity, irrespective of the initial state. So this study presents a novel sampling techniques based on random walks. This simple random walk sampling entails the progression from an initially selected node to a randomly chosen neighboring node, representing the transition probability from node v sub I to node v sub j. So in the context of random walk sampling, the transition probability for each node are determined through mathematical analysis. So this is the overview of proposed method. While gray nodes denote nodes capable of acquiring degree information and properties. So for example, you are staying at node 3, your sampling node is 4, but sampling node list is 3 and 4. So the input of the algorithm is just initial node, but the output is the sampling node list. So there are some definitions of probability of neighbor, probability of walk. But the important thing is feature estimation. We want to introduce an algorithm for feature estimation in the context of the proposed sampling algorithm. The primary objective is to apply weighting to the sample sequence generated by the proposed transition sampling algorithm, creating a process for estimating the expected value of features on the OSN. So this f here is just a function to the real number, and consider the uniform distribution. The expected value is just the average of them. So we can define function g by it applies the function to sampling nodes in the sample z sub t. Also, we can define this weighting function, 1 over sum of degrees. So as t goes to infinity, it converges to this expectation assured probability. And they did some experiments from Stanford Large Network Dataset Collection. The DBA model extends this Barabasi-Albert model to directed graphs by introducing directed edges from one node to another with this probability. And this is comparison between different models. You see NRMSE for a high degree estimation. So we introduced a random walk that stochastically utilizes information from adjacent nodes, considering the number of queries needed to obtain this information on OSNs as the cost. Through experiments, we demonstrated that our proposed method will have more accurate estimation of average degree, the proportion of randomly assigned binary labels, the proportion of labeled biases toward high-degree nodes, and the proportion of labeled biases toward low-degree nodes compared to existing methods.